unmute and let me know. But let's get started today. So thank you all for joining me for today's session on Introduction to Data Visualization. If you haven't met me yet, my name is Ashley Zeidler. I'm the Scholarly Communications Librarian here at MCW Libraries. A lot of what I do surrounds research data management, which does include data visualization. I also help faculty, staff, and students with copyright issues, publishing. Research metrics is also a large part of what I do here within the library. So if any of those are areas that you'll ever need help with, just keep me in mind. So today we're going to talk about data visualization. And like I said, this is an introductory course. At the end of the session, I will be deploying a poll that I hope you'll engage with and let me know your interest for future sessions as well. But today we're going to focus on discussing, so what is data visualization? Why do we want to visualize data? The steps to planning your data visualization, a few of the most common types of data visualizations or chart types, some best practices, and then some data visualization tools that are available to you. And within the slides, I do have links to some helpful tutorials that I think you might find useful in the future if you're looking to explore those specific tools. So let's get started. What is data visualization? So data visualization is a term we use to describe all the ways that people transform data into visual representations, which can then be used for understanding and communication. Generally, you can describe data visualization as anything that converts data sources into a visual representation, like charts, graphs, maps, sometimes even just a table. Data visualization is typically employed to either explore data or explain data. So when it's used to explore data, the creator is really trying to explore and understand patterns about their own research data. However, when it's used to explain data, the creator already understands those patterns within that data, and they're trying to create the visualization to explain those patterns to others. And because they're for an outside audience, explanatory data visualizations do tend to be a bit more sophisticated and planned out, while exploratory data visualizations are often created quickly and have multiple versions that are made sometimes in rapid succession as the creator digs through their own data and tries to make sense of the patterns. And on this slide, I included a quote from a really great resource, and it's linked here. It is a free book on fundamentals of data visualization. So if you are looking to explore this more, that resource is an excellent wealth of knowledge. But I have the quote from the author, so Klaus Wilke. I think it encompasses the topics we'll cover today quite nicely. So data visualization is part art and part science. The challenge is to get the art right without getting the science wrong, and vice versa. A data visualization, first and foremost, has to accurately convey the data. It must not mislead or distort. So my hope is that you'll leave today's session with a better understanding of data visualization best practices, as well as some of the common pitfalls we may encounter. So next, kind of looking at why do we even want to visualize our data? So good data visualizations allow us to reason and think effectively about our data. While we may be able to find a trend within the numerical data of our spreadsheet, it can take a significant amount of work to recognize and conceptualize that trend. So by visualizing the data, we can perceive the trend a little more clearly. So essentially, the importance of data visualizations are quite simple. It helps people see, interact with, and better understand data. Whether it's simple or complex, the right visualization can bring everyone on the same page, regardless of their level of expertise. And by combining data with compelling visuals, narratives can be created that captivate the audience and memorably convey complex information. Data visualization can also be useful for data cleaning, exploring data structure, detecting outliers or unusual groups, identifying trends, clusters, spotting local patterns, evaluating modeling output, and then presenting results. And a good example of why we want to visualize data is Anscombe's quartet. So this is where we see 4 data sets that share the same descriptive statistics, including mean, variance, and correlation. However, once we look at that data visually, immediately we can see that each data set has a very different distribution and is unique from the other data sets within the quartet. So now we want to look at data visualization planning. Of course, we can't just jump right in and start creating our visualizations, even if we want to. I know that's sometimes can feel like the most exciting part, to see the fruition of all of your research, but we have to start from the very beginning. So first, of course, like any project, whether it's data visualization, maybe completing a lit search, you have to start with developing your research question. So it's important to have a clear understanding of the goal of your research. This will determine what data is needed, the type of analysis that's necessary, and the type of visualizations that would be most effective to communicate your explorations or your findings. Next, you want to get or create your data. So you'll likely already have the data you need for your visualization if you're planning on using data related to your own research. However, if you're having trouble finding that data, or you just need data to practice with, feel free to reach out. I do have a list of curated resources. And then I do have to promote a shameless plug. Look out for a LibGuide specifically on finding data at the end of November. That's when I'll publish that. And I hope it's a helpful resource for all of you. Next, you want to clean your data. Now, talking about this could probably be an entire session on its own. However, briefly, cleaning your data really is an essential step to perform before you even want to create your visualization. So clean, consistent data will be much easier to visualize. Clean data is going to be data that's free of errors or anomalies, making it hard to use or analyze said data. Starting from a clean data set will allow you to focus on creating effective visualizations rather than trying to diagnose or fix issues while creating the visualization. And data cleaning tasks, they're really dependent on the data set you're working with. However, in most cases, these tasks are going to involve removing unnecessary variables, deleting duplicate rows, observations, addressing outliers or invalid data, dealing with missing values, standardizing or categorizing those values, and then correcting typographical errors. Then you want to choose your chart type. So it's important to pick a chart or a graph which will best communicate the message you're wishing to tell your audience. And the first step to choosing a chart is determine what message you're trying to deliver. So are you showing how variables compare to each other, showing relationships between variables, showing patterns within the data? Are you showing how the whole data set can be broken down into smaller parts? So picking one of these can help you select the chart type that will work best for you. And we will dive into chart types shortly. Then you want to choose your tool. So there are many tools to choose from, ranging from freely available open web-based tools to licensed desktop tools. And I'll share some helpful tools, like I said before, that are available to you for creating visualizations. And remember, there is a tool for everyone and at every skill level. Then you want to prepare your data. So the data preparation steps you'll need to go through really are going to be determined by the type of chart or visualization you'd like to create and the tool that you've chosen to create it with. So once you've selected your chart, you may need to perform transformations to create the required data. And tools like OpenRefine and Data Wrangler can help you with this process. But if we look at typical data preparation tasks, Those will typically include formatting your columns appropriately, so making sure numbers are treated as numbers, dates as dates. You want to convert values into appropriate units. Make sure you filter your data to focus on the specific data that interests you. And then think about grouping your data and creating aggregate values for groups, so counts, minimums, maximums, mean, mode, median, etc. You'll want to extract values from complex columns, and then finally combine variables to create new columns. And then of course we get to the fun part, creating your chart. So I just put down a few simple procedures that you would go about creating your chart. So you want to import the data into the software if it's not already there. Select the chart type you wish to create. Evaluate the effectiveness of the chart, which I feel like is probably the most important step here. And then you want to refine that by applying some design principles. And the way you design your chart will have a big impact on the effectiveness of the overall visualization. So now that we've talked about the data visualization planning process, we can look at the types of charts that are available to us. So we can break down some common data visualizations or chart types. So today I am covering, I think, 8 visualizations. And remember, this is not an exhaustive list. You may find better visualization types available for your specific data outside of my suggestions today. But before we jump into those, we want to remember that the primary purpose of our data visualization is to help viewers discover actionable insights. So when we're selecting a chart type, we should ask ourselves, what story am I trying to tell? Who's my data visualization for? What are their priorities? What problem am I trying to solve? What type of data do I have? Do I have categories of data? And if so, how many categories? So this information should give us a sense of what chart type would be most appropriate. So let's dive into each of the chart types. Of course, the one we're all familiar with, the bar chart. So a bar chart visually represents data using rectangular bars or columns. The length of each bar is going to correspond proportionally to its value. And you can present these bars horizontally or vertically. And then just a note on that. So a horizontal bar chart is definitely going to be the best option if the text on the x-axis of a vertical bar chart is lengthy. So if you need to present it diagonally or cut it off, you do want to look at flipping the orientation and making that a horizontal bar chart instead. That's much better for readability, clarity, accessibility. And these types of charts are going to be excellent for comparing values of different categories or groups. But apart from that, they're also helpful in showing distribution of data across different categories. So some best practices for bar charts. You clearly want to label each bar and axis with concise labels. Limit the number of bars or categories to avoid cognitive overload. And then you purposely want to use colors to highlight key points or convey meaning. Now we can look at the histogram. So a histogram visualizes a single continuous data set. Although sometimes histograms and bar charts can be used interchangeably, they do differ in practice. So while the bar chart is a plot of a single data point, so a sum, an average, or some other value, for each category, a histogram is going to be a plot of a range of data. So histograms work best when displaying continuous numerical data. So if the user wants to analyze the average number in a group of measurements, the histogram can give the viewer a grasp of what to generally expect in a process or system. And I think lately, we all see these histogram. Where I see it most often is on Google. When you're looking up a specific restaurant you want to go to, you see the histogram of the busiest times of that restaurant. So just a way that someone's putting into practice data visualizations to quickly share information with restaurant patrons. But some best practices for histograms: you do want to choose an appropriate number of bins and their sizes. Consider using consistent intervals for the bins to maintain uniformity and accuracy in data representation. And then ensure you have sufficient data points to create a meaningful histogram. So histograms are definitely less effective with smaller data sets. So next we have the line chart. So a line chart is going to use points connected by line segments from left to right to demonstrate changes in value. The horizontal axis depicts a continuous progression, a length of time, while the vertical axis reports values for a metric of interest across that progression. So this type of chart is going to help you measure how different groups relate to each other. It can also be effective in demonstrating progression, making them suitable for scenarios like project timelines, production cycles, or population growth. Some best practices to consider for creating a line chart is to ensure that your data, the data you're representing, has a logical order. Add context through annotations and labels. And then if the data set is large, use transparency or spacing to improve visibility. Next, we have scatter plots. So scatter plots, their primary uses are going to observe and show relationships between two numeric variables. The dots in a scatter plot not only report the values of individual data points, but also patterns where the data are taken as a whole. So identification of correlational relationships are common within scatter plots. You'll often see the variable on the horizontal axis denoted an independent variable, and then the variable on the vertical axis as the dependent variable. So relationships between variables can be described in many ways: positive or negative, strong or weak, linear or nonlinear. And a scatter plot can also be useful for identifying other patterns within the data. So we can divide data points into groups based on how closely the sets of points cluster together. They can also show whether there's any unexpected gaps in the data or if there are any outlier points. So a few best practices when working with scatter plots: you definitely want to make sure you're highlighting outliers if present within the graph to showcase data distribution. Add a trend line to highlight the relationship between variables. And then consider using different colors or marker sizes for overlapping points. That's definitely important when you are using a larger data set than the one that's shown in the example here. And then our trusty pie chart. So really, pie charts do have a fairly narrow use case that's encapsulated pretty well by its definition. So in order to use a pie chart, you must have some kind of amount that is being divided into distinct parts. So your primary objective with a pie chart is going to be comparing each group's contribution to the whole, as opposed to comparing groups to each other. So if these points are not satisfied, the pie chart really isn't appropriate, and you want to choose a different chart type instead. But if you are looking to create a pie chart, you just want to keep in mind keeping the number of slices limited to create or maintain clarity. Clearly label each slice with clear text, and then ensure consistency so viewers associate colors with specific categories. Then we have the tree map, which I feel like sometimes can be a favorite when people are just diving into data visualizations. It does seem like I see these quite often, but tree maps are hierarchical charts that allow you to visualize data as nested rectangles. And these rectangles or branches convey the structure and distribution of the data, which actually makes tree maps really useful for visualizing categorical and hierarchical relationships. But apart from visualizing hierarchical data, this type of graph helps illustrate part-to-whole relationships within a data set, so it demonstrates how each category contributes to the overall composition. And a few best practices for tree map charts would be ensuring that the size of the rectangle is proportional to the size of the category, clearly labeling each rectangle with concise labels, and then using a single color with varying shades to show changes in the data. Next, we have a heat map. So heat map charts are a type of data visualization that uses a system of color coding to represent value. So each cell in the matrix is assigned a color based on the value it holds. This type of chart is commonly used to establish relationships between variables across a grid. Heat maps offer several advantages. So they're eye-catching and draw engagement using their color, and they allow us to see the data with more granularity compared to the aggregated information usually presented in a line or a bar chart. And then some best practices for heat map charts would be choosing an intuitive color palette that effectively conveys the magnitude of values, use visual cues to highlight significant values within the heat map, and then utilize the design principle of white space to prevent overcrowding within the visualization. And the last data visualization type I'm going to talk about today is the box plot. So box and whisker plots or box plots are a great chart to use when showing the distribution of data points across a selected measure. So these charts display ranges within variables measured. This includes outliers, the median, mode, and then where most of the data lies within the box. So these visuals are helpful to compare the distribution of many variables against each other. So you want to use a box and whisker plot to show the distribution of data within a population. They'll offer users a way to determine where most of the points land at a glance. And then they are even more useful when comparing distributions between numbers of a category in your data, or between members of a category within your data. So best practices for box plots are going to be comparing multiple groups. So box plots are really the best when they're used as a comparison in distribution needs that need to be performed between groups. And then you want to consider the order of the groups. So if the groups are plotted in a box plot and they don't have an inherent order, you may want to consider arranging them in an order that highlights patterns or insights. So a common way to do that would be to sort them by median value. But now that we've covered a few of the chart types, and like I said, these are the ones I felt were most commonly used, maybe the most introductory, but there are so many out there available to you. Even in the tools I'll share in a little bit, there are many different visualizations you can use to represent your data beyond the ones I shared. But if we want to look at data visualization best practices, we do want to think of a couple things. So creating an effective visualization really can be challenging. You know, how do we grab and keep people's attention while also effectively communicating our data insights? So I wanted to discuss some best practices for data visualization, which will help ensure that your visualizations are clear and informative, and that your insights land as intended. So first, which I feel like is the #1 best practice that people do talk about when talking about data visualization. So know your audience. An effective visualization of data should be relevant to the intended audience and convey meaning. So it's important to match your visualization to your audience's information needs. Ask yourself, what are they looking for? So what types of decisions is your audience making? What information do they already have available? What additional information can your chart provide? Do they have time or interest to explore an interactive dashboard? Or should you really design a static visualization that could be understood just at a glance? So while interactive dashboards are powerful tools that allow users to select the data they're most interested in, run their own analyses based on questions they pose, some users just don't have the inclination or capability to explore a data set or the baseline knowledge to pose meaningful questions. So for those users, a static graphic would be more effective in conveying information. Next, you want to remember to keep it simple. So data visualization is all about communicating data insights in a way that's both accurate and easy to understand. So when creating visuals, less is almost always more. Too many visual elements can be distracting. It leads to cognitive overload. So it's essential to use simple charts that help you make your point straight away. Excessive labels, jarring colors, overly complex charts, they can tend to be misleading. So to ensure that your graphics are created in a way that makes the main takeaway crystal clear, here are a couple questions that I would consider. So is the chosen visualization the simplest, most effective for the data and my message? Are the axes and labels clear? Are they easily understandable? Is the data presented in a logical and intuitive order? And is the visual clutter minimized? So these are all important questions when we want to go through the process of evaluating the effectiveness of our data visualization. And of course, we want to use intuitive visual cues. So you can use shapes, colors to show that categories, subcategories, or levels of your data. They can indicate the status, direction, relationship within your data. However, you do want to use colors that match your subject. So while a visualization doesn't necessarily need to use color at all, you do want to make sure that it's not misleading in any way. And if your visualization doesn't need to use color representatively, maybe consider sticking to organizational brand colors just for consistency. But remember, if your visualization doesn't need color, you don't have to use it. So you just want to resist the urge to add color for the sake of adding interest to your visualization. You also want to consider accessibility and cultural implications of your color and shape choices and how they might affect your viewers' perception or interpretation of the data. And then something to keep in mind. So if color is the only way you're conveying meaning, your information might be lost on someone who can't see color. So instead of relying on color alone to explain the data, you want to add additional visual indicators. So patterns, shapes, even text labels, so that even if someone's unable to perceive color, they can still understand the data. And then using effective labels. This one is extremely important, I found, when, again, trying to find examples. You really do find like the spectrum of data visualizations out there, from very good to not great at all. But text on data visualizations can come in the form of labels, a summary paragraph, a title, a legend. So this text is there to enhance the interpretation of the visualization. You don't want to take attention away from the data. So specifically, labels are important for any data visualization, and they should be clear and concise, and they should accurately describe the data that's being represented. So when you're labeling your data visualization, just keep in mind, so too many labels or too few labels can interfere. So take a step back from the visualization and ask yourself, is this visually easy to read based on how the labels are laid out? Are there too many labels? You do want to avoid the temptation to clutter your visualization with text. So if you find yourself needing to explain more with text, consider whether your data is saying enough. If you really do need more explanation with text, be sure to highlight the most important part for your reader. Your goal should be clarity. A short call-out sentence or a paragraph can be helpful. And then if you do so, maybe consider highlighting the most important takeaway within that, maybe using a different color or a font, bold or italics, so that the viewers notice that first. You also want to think about avoiding misleading visualizations. So with the rise of use in data visualization software, we're bound to see poor or otherwise inaccurate data visualizations. Just as well-crafted data visualizations benefit organizations that generate and use them, poorly crafted ones can create several problems. So inaccurate data visualizations can lead your audience to have a false understanding of the data that's presented to them. And this misunderstanding can lead to incorrect insights, organizational decisions, all under the guise that they're backed by data. So important things to remember: always start your axes with 0. Never change the aspect ratio of your visualization. So if you complete your visualization and then use it as an image within a presentation, do not stretch that image to create a disproportion within the visualization. Next, you do not want to hide important data. So sometimes, to make a point seem stronger, it is tempting to leave out important data of the visualization or hide unfortunate data that's still really pertinent to the purpose of said visualization. And then too much information can confuse people. So if you present too much data at once, people won't know what to focus on, and they may choose the wrong data to place that focus. Next, you only want to group elements that relate to each other. And then finally, don't use colors that mislead. Make sure your colors are intuitive, that they make sense, and that they wouldn't cause any accidental misinterpretation. Next, we can look at incorporating interactivity. This, I feel like, is quite popular now in a lot of organizations. The idea of creating data dashboards have really come to the forefront. And interactivity encourages users to explore the data and uncover any hidden insights. So with all of these new or newer data visualization tools, users can apply filters. They can drill down into details. They can ask questions using conversational analytics. These interactive activities can empower stakeholders to gain a hands-on understanding of the data. So essentially, interactivity can provide a more immersive experience that allows users to explore the data in greater depth. It can reveal patterns and trends that may not be immediately apparent in a static visualization. It can allow users to manipulate the data to reveal different insights. And it can be engaging and visually appealing to users more so than static visualization. But we do have some best practices when we think about incorporating this interactivity. Of course, we want to keep it simple. Too much information is going to be overwhelming. We do want to stick with the most important data points and allow users to explore further if they want more detail. Then we want to make it visually appealing. So an interactive visualization that's well designed and visually appealing will be more engaging for our users. We also want to think about using intuitive controls. So users should be able to easily understand how to interact with the visualization. We want to keep our controls simple and consistent. And then be sure to provide clear guidance. It should be clear to your users what they can do with the visualization and how they can get the most out of it. So tool tips, legends, and other guidance can be helpful in providing this context. So I've covered all of the best practices I wanted to share today, and then I wanted to dive into some of the data visualization tools that are available to you. Now we can start with the most basic, the one everyone knows, so Microsoft Excel. Now technically this is considered a spreadsheet software. It's not a data visualization tool. However, it does have useful data visualization capabilities. You can use Excel to design over 20, I think, chart types using the data within your spreadsheets. So common chart types, bar charts, pie charts, scatter plots, but it can also create radar charts, histograms, tree maps. However, if you are looking for a more powerful data visualization tool, but are still looking to stay within the Microsoft ecosystem, Power BI can be an excellent alternative. It's built specifically as a data analytics and visualization tool. So it can import data from various sources and then output visualizations in a range of formats. Then I have Tableau. So this is the one that I personally do use to create our library dashboards. So this one, I guess I do have bias towards because I'm more familiar with it, but it is one of the most popular data visualization tools on the market. It's really easy to use, and it's also incredibly powerful. This software can integrate with hundreds of sources to import data. It can output dozens of visualization types from charts to maps and more. And then what's also good to note is that there is a free option, and it's called Tableau Public. So this is available to anyone. But it is important to note that any visualizations created within Tableau Public are available for anyone to see. So this makes it a great option to learn the software's basics, but it's not ideal if you are working with proprietary or any sensitive data. So just keep that in mind if you're looking to explore Tableau before making a purchase. I do think they have either discounted rates or other options for students and then teaching faculty. So that's something to consider as well. Then we have Google Charts. So if anyone's interested in creating interactive data visualizations that are intended to live on the internet, Google Charts is a popular free option. So this tool can pull from various sources, including SQL databases, Google Sheets, if you're using that. It also uses HTML5 SVG technology to create charts. So it makes them incredibly accessible, and it offers 18 chart types. So a lot of the common ones I talked about today, but also geo charts and area charts. Then we have Data Wrapper. So Data Wrapper is like Google Charts in that it's used to create charts, maps, and graphics for use online. So some common outputs are scatter plots, line charts, stack bar charts, a variety of maps and tables. And their focus is on beautiful design defaults. They have an easy interface. They're responsive, and they do offer PDF and SVG exports, although most users do create the visualizations to embed somewhere online. However, if you're already working with a scripting language for other aspects of your data analysis, you're in luck. You can also use that same software for everything from data cleaning to data visualization, both numeric and text data. So I highlighted R. So it's not only a standard statistical analysis tool, but it's also pretty powerful for data visualizations. So R uses the ggplot2 package, and this is their primary graphic making package. However, there are numerous other packages meant to extend the functionality of ggplot2. So from animations to maps to other advanced graphic options, the extensions can help you make, I'd say, what you could consider publication-worthy graphs. And those working with text data, there's the TidyText and TM packages, which are good for cleaning, analyzing, and visualizing text data. And then I highlighted Python. So like R, Python has libraries to create impressive visualizations, while Matplotlib is the main graphics library. There's also additional Python libraries focused on visualization, including making interactive plots and charts, 3D images, maps, and even more. And that brings me to the end of what I had to share with you right now. But I wanted to save time for questions because I know we had quite a few people attend today. But as I'm pulling up the poll, if you can feel free to unmute yourself and ask a question, put it in chat. I can read it from there. But I'm going to launch this poll, hoping to gauge your interest in any future topics that you'd be interested in for data visualization. And then I also included research data management topics as well, because I'm looking to create quite a few more offerings in the spring. And I don't want to base that on, my own personal interest. I'd like to gauge where your interest lies and create sessions that are actually helpful for you. But are there any questions? I do have all of our contact information here on the screen. You can feel free to reach out to me individually. However, if you're already on our website, all of our information is here. So if you have questions specifically on data visualization or research data management, that can get forwarded to me. And thank you all for attending. I see some people in the chat there. Yes, Tallulah.
Oh, hi. I just wanted to say thank you. I didn't quite be able to catch your full presentation, but I just wanted to say thank you for doing this. It's really helpful coming from someone who doesn't have a lot of experience with data visualization. So kind of having this as an inroad to learn more is great.
Good, I'm glad to hear it. I was just putting this in the chat. So yes, I can share out my slides, and then the recording of this session will go onto our YouTube channel. So if you're on YouTube, just look up MCW Libraries, and that's where all of our recordings live. So if you're ever looking to visit, revisit a session or share it with your colleagues, YouTube's a great resource to do that. And then again, if you have questions, feel free to email me anytime. I'm happy to chat online, set up a Zoom if you want to talk about anything. But otherwise, thank you for your time. I hope you have a wonderful rest of your morning, afternoon, and thank you to everyone who participated in the polls. That will help me design some future sessions that I hope will be helpful to all of you. Yes, I will send those out, Daria.
Thank you. Bye.
Thanks. Bye, everyone.